Hello, my dear. Welcome to the IMS GATE Academy. I am Pragyabrat Tripathi. I hope you are all doing well and your preparation going in a right direction. So, my dear, we are continuous with that same series to the next level of the some more important problem. Okay. So, till now we have to discuss about the properties of the fluid and some questions left, and there is a fluid static, fluid kinematics, fluid dynamics and boundary layer. Today we will complete, no problem. So before that, let's start. Okay, beta. So one second, beta. Like this is all complete. Okay, this one is also, this one is also, this one is also. You have to complete it. This one, this questions also done, no problem. This questions also done, this questions also done, this question also done. Now this is the same question. This is the surface properties question, surface tension. So this questions based upon the surface tension, right? Surface tension, and there is a application of the surface tension node capillarity. Capillarity, okay? So capillarity, this is the question on based on a capillarity, right? Okay, no problem, beta. See, this is the capillarity. Okay, this is the capillary. See, there is a capillary tube. There is a capillary tube, okay, of a diameter d. This is a diameter d of a capillary tube, and its inclination is theta. Theta is the inclination. Okay, theta is the inclination. Okay, beta. Now, the liquid which is raised in the capillary, of a length L. This is the L length of the liquid will rise. Okay, beta. So, what is the concept here? How this length, this much of the fluid will hold into the capillary tube. That means कितना fluid इस capillary tube में L length तक hold है, ये कौन hold कर रहा है? Which is hold that fluid? That means if you think that this is a capillary, and if there is a fluid, right, and that fluid will raise or either fall, this fluid will raise. So this much of amount will be rise. This is a rise of the fluid through the capillary. So this amount of the fluid will be rise. That means which force, this is this fluid have a weight W downward. Which force is balanced of this weight? कौन सा force, which force is balanced to hold this weight? That means which force is responsible to holding this weight? The force is nothing, the force is surface tension. That means due to surface tension, properties of surface tension, this weight of this height of the column, is holding. That means if there is any capillary tube, the weight will rise or depreciation. That weight is holded by the properties is known as surface tension. Due to the property of the fluid of a surface tension, the capillary rise or capillary fall. So, so beta, this weight will be holded by the surface tension action. This is the surface tension action. So this is the problem of the surface tension. So we'll define a one second, beta. Where it is? Okay. So we draw the free body diagram of this capillary tube. We draw the free body diagram of this capillary tube. This is our capillary tube. This is our capillary tube. This is our capillary tube. Okay. This is our capillary tube. This is the force. This is the force. See, this is the water. So the contact angle is 0 degree. This is the surface tension, coefficient of surface tension. This is the length L. This is the weight downward of this fluid element. This is the weight of this fluid element. This is the weight of this fluid element, and this is your normal direction. This is your normal direction. This is your normal direction. That means this is nothing. It is not important in this question. So why? Because we balance the force along this axis X. So this is not important, but we have a force balance. That means this is chunk of the fluid. On the chunk of the fluid, there is a weight is acting downwards, and due to the surface of this glass tube, the normal force will act on the fluid element. But don't bother about that. And the angle, it is given theta degree. So just a force balance. So this angle is also theta. This, if we W component, this is the W component, this is this W component, we have to balance it. That means net force in X direction is equal to 0, and you have to balance it. Force balance. So this capillary action, this surface tension is the surface tension. It is a line force. Surface tension, it is a line force. So it is throughout the surface. That means this is your surface now. If this is your surface, then this is throughout. This is throughout. Surface tension throughout the periphery. This force, and you take a component of this one, sine. So along this W sine theta. This is your W sine theta. It is in this direction. So this surface tension force is balanced by this force. That means this sigma into this cross section area, not cross section, this is the perimeter. This is the length, not area. This is the length. See, my dear friend, this is the length, pi d. This is your pi d. Pi into 2 pi r. This is your 2 pi r, pi into d. So area, it is not area, it is a parameter. This is a parameter, this length. Okay, this one. So this is the parameter AP is equal to weight W sine theta, and this is your W. How to calculate W? This is your W. W is equal to, what is the weight? Density. Density is equal to mass by volume. You multiply G. This is your weight. Then weight is equal to rho G into volume. And this is the volume of the fluid which is contained in the side of cylinder. So this volume, this is your cylindrical, and this volume is contained inside the cylinder. This volume, this is the length L. This is the length L. Right, beta? This is the length L, and this is the diameter D. So you have to calculate easily volume. What is that? Pi dl. This is the area cross section, pi r square into L. Right? So this is your volume, and this volume you put, this is your weight. I give you a final expression. 1 second, beta. Hold on. Hold on. 1 second. I give you the up to that you have to solve it. I give you 1 second, beta. I give you, no problem. So this is your final. I give you, no problem. Just hold it. So just you solve it with your own force balance, right, beta? Force balance, just solve it. Just solve it. Force balance. Just solve it. Just solve it. I give you some brief. Okay. So this is your, no problem. Okay, beta. This is your Okay, so what is the final expression? So what is the volume of this? See beta. So what is the force? Net force in the x direction. So you have to balance it. What is the weight? Weight. And what is the volume? You have to calculate the volume. Volume is what? This is your length L. L length, up to L length, the fluid is holded, and there is a diameter D. So what is the volume? The volume is pi r square. R is D by 2. Pi r square into L. This is your volume. This is your volume. So rho g into this one, into what is the perimeter? What is the perimeter? The perimeter is pi into D. This is the perimeter. What is the perimeter? Pi into D. So, not next page add. So, if this is your tube, okay, so only you have a component. This is your length L. This is your diameter D, right? In this direction, there is a W sine theta, right? This is your weight W, and there is a surface tension sigma into L, sigma into L, right? Surface tension is the line force. So you have to balance this. W sine theta is equal to sigma into L, and the W you have to calculate it, see, pi into D, right? This W you have rho g into volume. Volume is pi by 4 D square into L. Now you have to equate it. From that equation, you have to calculate what is that? What you want to calculate? What is the length? You have to calculate the length. The length is, the final expression is beta 4 sigma divided by rho g d sine theta. This is your final expression. Rho g d by sine theta. So this is your final expression. Now, if theta, see, if this is a theta, okay, now this is the theta. From this there is a theta. Okay, this is your theta. Okay, beta, this is your theta. If theta is 90 degree, if theta is 90 degree, this is the theta. See, previous slide. This is theta. If theta is 90 degree, if theta is 90 degree, so in this case, if theta is 90 degree, simply if theta is 90 degrees, sine 90 is 1. Sine 90 degree is equal to 1. Sine 90 degree is equal to 1. So what is the, for vertical, what is that? 4 sigma, and you know this, rho g into d. You know that. So only the difference is, if there is a angle, if there is any capillary tube, if there is any capillary tube and this angle is 90 degree, so you have this one. If there is any inclination from the surface, if there is any inclination, that means now if this is your surface of the water, surface of the fluid, and this capillary will incline to angle theta, only multiplied denominator sine theta, that's it. That means you have a knowledge about what is the rise. This is your rise, along the rise. So what is the rise? You know that L is equal to 4D by rho g 4 sigma. L is equal to 4 sigma by rho g d, and you multiply here. That means there is a factor rho g d, and you multiply, is equal to 1 by sine theta, is equal to 1 by sine theta, is equal to 1 by sine theta. So 1 by sine theta is the factor due to inclination. This is the inclination factor. This is the inclination factor. If there is a horizontal, theta is 0, there is no any meaning. Okay? Okay, beta? Good evening, beta. Thank you, Saurabh. Okay, now next problem. Next problem, this one. So this is your next problem. Please see and read carefully. See, this is your next problem. What is that? Please see. This is your next problem. I have also already calculated, and we match the from the our explanation already done. So this is your questions number second. Today's question number second. Okay, beta. Now, see the semicircular plate. This is your semicircular plate. Semicircular plate. 1 second. This is semicircular plate, right? This is your semicircular plate. Okay, now this is your semicircular plate. This semicircular plate, at this side there is a water. There is a full of water. There is a full of water. There is a full of water. Okay, no problem. And there is a hinge. This is your hinge. At this point, this is your hinge. And this point there is a contact point. Okay. This side there is a fluid. There is a fluid, right? And this semicircular plate have a radius 3 meter. How much radius? 3 meter is the radius of this plate. 3 meter is the radius of this plate. 3 meter is the radius of this plate, right? A semicircular plate in the figure 4 meter long. Long in the sense, matlab, that means this plate, right? This plate, if you see like that, so this is your depth. Long, that means depth. What is here long? Depth. This is your depth. That means inside the page, perpendicular to the page, length is given 4 meter. Okay, no problem. That means it is like that, beta. This is semicircular, na? 1 second. It is like that. This is your plate. It is like that. This is your, it is like that. It is 4 meter. Okay, it is plate like, thin plate like. Okay, 4 meter. Okay, beta. As a gate in a channel, there is a channel. Determine the resultant force that water pressure exerts on the plate. Resultant force, यानी net force निकालना है. Resultant force due to water which is holding by the semicircular gate. Water present plate, and then find the component, or also find the components of the reaction at the hinge. That means this point there is a hinge, and we know that how many forces acted on the hinge. There is only 2 forces, horizontal force and vertical force. That this at the hinge there is a force Bx and By. So you have to find it this one, right? At hinge, and at the smooth support there is a support. Why there is a line smooth? They see it is not at as a that you have very attractive question you make, and this मतलब ये ऐसा नहीं दिया हुआ है कि सिर्फ दिया हुआ है smooth rough, ऐसा नहीं. This have a meaning. If there is a smooth, then that means you don't consider any friction in between the gate and the holding side. So it is smooth. That means there is no any friction other than the reaction. There is no any rubbing other than the reaction. Yes. Neglect the weight of the plate. Weight of the plate is neglected. That means self weight. The weight of the plate is neglected. That means at this point there must be. That means see. That means if there is a water is here, what is the force exerted by the water on the plate? First you have calculate net force, right? Second, what is the reaction at the hinge? Third, what is the force? What is the reaction at A? That means RA. You have to calculate. Yeah, force at A. Yeah, force at A. FA. You have to calculate it. Okay. Now, the net, see, determine the resultant force. Determine the resultant force. Determine the resultant force. Thank you, Parnay. Thank you, beta. Determine the resultant force. See, the resultant force, that means net hydrostatic force. Yes, 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 yes. Up to a free surface. Very correct. Up to a free surface. Up to a free surface. Up to a free surface. Thank you. Okay. up to a free surface. Now, see resultant force. See the hydrostatic force. The hydrostatic force is what? Resultant force. And this is net. That means hydrostatic force horizontal and hydrostatic force vertical. Right. See, if there is a curved surface, if there is any curved surface, on that curved surface, the hydrostatic force have a two component. Atmospheric pressure, why you calculate all the calculation? Atmospheric pressure, why you are calculating atmospheric pressure? Hydrostatic pressure, in the case of hydrostatic force, we cannot calculate any atmospheric pressure. Why? Because all the process we can consider on the gauge basis. We cannot consider on the absolute pressure. If you consider absolute basis, then you may consider atmospheric pressure. You don't consider anything. Okay? It is also not given. Okay, beta? It is not given. If it is not given, if there is a variation in a fluid static, mind it, in a fluid static or in the, or the curved surface, there is no, if there is no any pressure is given, don't confuse it. Okay, don't calculate it. There is no any extra effort. Only there must be a horizontal force due to hydrostatic force, hydrostatic pressure, and vertical force due to hydrostatic pressure. That's it. Okay. Now. So, see, resultant force is the hydrostatic force, right? And reaction at point B. Now, what is your approach? Please, anyone? What is your approach? What is your approach, beta? Please, anyone? What is the approach? How to calculate? Please, anyone? How to calculate, beta? What is your approach? First, what is the pressure variation? See, the fluid which is outside from the curved surface, it is not inside the curved surface. So, this is our diagram. See, very important. See, if you draw, this is our curved surface, yes or not? This is our curved surface. This is our curved surface. Okay, this is our curved surface by pressure diagram. Okay, you just calculate it. So, this much amount of the fluid we have supposed to be taken into consideration. Okay, this much amount. So, first we calculate the horizontal force. We have to calculate horizontal force, right? We have to calculate horizontal force. We make a diagram, no problem. See, this is your horizontal force. The curved surface we project vertically. If you calculate horizontal force, the projection is vertical. If you calculate vertical force, your projection is horizontal. Okay. See, we draw like that. There is a curved surface. Okay, there is a curved surface. Okay, beta. This is the point A. This is the point A. Okay, this is the point A. There is a support which is fixed like that. Okay, there is a hinge. At this point, there is a hinge. There is a hinge. Right, on that hinge, this is point B. This is point A. Okay. Now beta, if we take horizontal force, we draw a vertical component. So, this is your water level. Okay. So, we draw a vertical projection. Up to this one, we draw a vertical projection. No problem at all. We draw a vertical projection. On this vertical projection, there must be a pressure variation. If you take a atmospheric pressure, you may take, but ultimately it is cancelled out. So, we take a pressure as a gauge pressure. At that point, the atmospheric pressure is 0, and we are going inside the fluid, the pressure intensity will increase, and the pressure intensity is maximum at this point. This pressure is maximum at this point, and their point is 0. So this is your pressure variation. 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 Okay. This is your pressure variation. No problem at all. What is that? This is your pressure variation, and in this pressure, this pressure will be ultimately affect the horizontal force. Ultimately affect the horizontal force, and this horizontal force, we know that it is act at a center of pressure. What is the center of pressure? The center of pressure, it is a CG of this pressure prism. It is the CG of this pressure prism. That means the center of the center of the pressure, that means horizontal force, जो horizontal force होगी बेटा FH, जो horizontal force होगा FH, जो horizontal force होगा FH, वो कहाँ लाएगा? Where it is the position of the horizontal force? Where is the position of the horizontal force? It is the CG. It is the CG of the pressure prism. It is the CG of the pressure prism, and CG of the pressure prism, and it is the center of pressure. CG of the pressure prism in the center of pressure of the hydrostatic force, horizontal hydrostatic. The center of the pressure, net horizontal force passes through the CG of the plate, not CG of the plate, not CG of the plate, beta, not CG of the plate, CG of the pressure triangle. This CG of the pressure triangle, not CG of the plate, not CG of the plate. This CG of the pressure triangle. So that means this FH, this horizontal force will act as the CG of this triangle. CG of this triangle. CG of the triangle is the CP, center of pressure of the net hydrostatic force. So center of pressure and CG, don't confuse. If you find, I am again repeating, if you find the center of pressure, why we find the center of pressure? Why? Because we can find out the location at where the horizontal force will act. The location at where the horizontal force is act at CP, center of pressure, and the center of pressure by default, it is the center of gravity, CG of the pressure variation or pressure prism. It is clear? Okay. So this is your a point. This is your center of pressure. This is the point of center of pressure, and this center of pressure is also CG of pressure prism, a pressure triangle. Yes or not? Pressure triangle. Mind it. Okay. Now, what is this horizontal force? We know that this. See, this horizontal force is also in the net direction. This horizontal force, that means FH is equal to what, beta? Rho G. Huh? Please. Rho G into height of the CG. Height of the CG. That means height of this vertical projection, very important, height of this vertical projection. So this is what height? CG is vertical projection, क्योंकि बेटा इसका vertical projection तो यही है ना, इस प्लेट का vertical projection, that means यही तो प्लेट है ना आपका, this is your plate ना, vertically. तो इसके CG, that means H of C, this is your, and area, and area. What is the height from the free surface? Yes. Height HC, height from the free surface. This is our free surface. This is our free surface. So this HC, this is your HC, and HC is the CG of this plate, is the CG of the plate, and CG of the plate just half of the, what is the total length? The total length is the C. The total length is 6. How much the total length? 6 meter. So the CG of this vertical projection is 3. So this is your 3 meter. Okay. So HC is what? 3. What is the area? Area of this plane? See, the depth. See, for calculation of for the calculation of horizontal force, this horizontal, it is not necessary that this horizontal force is act at CG. See this, that means you have a lack of basic derivation. Go through the derivation. This is the centroidal pressure. This is your centroidal pressure, rho GH, yani pressure at the center of the vertical plane. That means what is the force will act, and that what is the force will act on the plate in the horizontal direction, it is at the CG, up to the CG from the free surface, up to the free surface. That means, that means this is your plate now. I am showing you. 1 second. This is your plate now. Horizontal component, vertical direction. So the horizontal force, okay. The horizontal force is act at the center of pressure. The location of the horizontal force is at center of pressure. And what is the center of pressure? Center of pressure is the CG of the pressure triangle. It is clear, no problem. And what is the formula of hydrostatic force? Horizontal hydrostatic force. The formula of horizontal hydrostatic force is the, what is the force? Pressure into area. What is the force? Pressure into area. What is the pressure? Pressure is the centroidal pressure. That means pressure at the CG. What is the, whose CG? The vertical plane of the CG. Okay, the vertical plane of the CG. Okay, thank you. So what is AC? 3 meter. Right? What is A? A, the height is total 6 and width is 4, I think. No? So this is 6 into 4. 6 into 4. So calculate it. If H is equal to rho G 9810 into H is 3 into area 6 into 4. How much it is? Just calculate how much? How much it is? It is your 706.32 kilonewton. Right? और ये कहाँ लगेगा बेटा? Where it is act? It is acting at CP. It act at CP. And what is the CP? What is the location of the CP? What is the location of the CP, beta? Where the CP is located? See, CP is the CG of pressure triangle. So, this is our pressure triangle. This is our pressure triangle. This is our pressure triangle. Yes or not? This is our pressure triangle. So what is the CG of this pressure triangle? From the base, it is h by 3. From the base, it is h by 3. So from the base, if you take a base, this is at h by 3. This is at h by 3. So this is your h by h. That means total height. you just write total height. You just write total height. No problem at all. That means this is at 6 by 3. That means 2 meter. From the base. This is from the base. That means this is your 2 meter from the base. This is the hydrostatic force. Okay. This is your hydrostatic force. H by 3 from the base. From the peak to H by 3. Okay. Now we calculate the vertical force. Now we calculate the vertical force. See, for calculating the vertical force, see, this is your fluid, top side fluid, and this is your bottom side fluid. Okay, this is your bottom side fluid. That means if you take, if this chunk of the fluid, if you calculate force, vertical force due to this chunk of the fluid, vertical force due to this chunk of the fluid will act a force on this segment AB. The segment AB, this vertical this fluid will act that means, see, there is a two part ना, दो part है ना इस कर्व का. One part is AC, other part is CB. The segment of the part AC, on the segment of the part AC, the fluid exert a force in this direction. Yes or not? And the segment of the part CB, the fluid act as in this direction. Because in the curved surface, all the forces have a concurrent. So if we meet any point, this force meet at a point. This is called concurrent force. So, good evening, sir. Good evening, sir. Good evening, Atul. So it is at a concurrent side. So the analysis of the curved surface and the flat surface is differ. The analysis of the flat surface, the force are parallel. So only one component is there. But in the case of curved surface, the forces are concurrent. That means meet at a point. On the plane surface, the forces are parallel. On the curved surface, the forces are concurrent. So it's have a two component. One is horizontal, other is vertical. So you have to calculate the horizontal force. You have to calculate the horizontal force, net horizontal force. Now you have to calculate the vertical force. Now you have to calculate the vertical force. So this is the resultant force. This is your net force. This is your force. Yeah, you may say that this is a force. So this force have a two component. One is the horizontal, other is vertical. This force have a two component. One is the horizontal, other is vertical. Right? So due to this force, you just have to calculate it. Net horizontal force. You just have calculated net horizontal force. Now the net vertical force you have to calculate. Then you have to resultant force due to hydrostatic force. Resultant force. Resultant force Fr. This is equal to square root of F horizontal force plus F vertical force. Why? Because both are at 90 degree, so the cos component is gone. So this horizontal force just now you have calculated. This is your horizontal force. Now you have to calculate the vertical force. So from the vertical force, there are two segments will consider into picture. One is the top, other is the bottom. The bottom portion of the chunk of the fluid will exert a vertical force in upward direction. The upper portion of the chunk of the fluid will exert a force in downward direction. So if you calculate the hydrostatic force, if you calculate the component of hydrostatic force in a vertical direction, you just project it on the free surface. So if you take this part of the chunk, if you take, this is your one part of the chunk, so this part you project it on a free surface, it at a free surface, project it at a free surface, project up to a free surface. So this portion you have to calculate. This is nothing. This is what is the weight content within this fluid element, right? So this, due to this chunk, see the beauty, due to this chunk, this much amount of the force in upward direction. That means this is your FV1, and due to this chunk of the fluid ADC, this is your A, that means the curved surface A to C, this is your A to C, we have considered it. So you project it on a free surface, project it at a free surface, and this is, and this is in downward direction. This is in downward direction. So this is your downward direction. This is your downward direction. Now, one is upward, other is downward. We have to calculate, this is net vertical force, this is net hydrostatic force. The net vertical force is the vertical force due to lower portion minus vertical force in upper portion. Why? Because both are the opposite in sense. If we take this much amount of the fluid, weight of this fluid, and we take weight of this fluid, add this, so this only this portion you have to consider it. Why? Because this portion and this portion are same. So only this portion you have to bother it. Only this portion. Only this portion you have to consider it. No problem. Only this portion. So what is the vertical force? Weight content inside the curved surface up to free surface. So if you consider this and this portion, only picture आपके दिमाग में यही आएगा कि what is the fluid content within the curved surface A, C, B, A. That means A to C, C to B, B to A, B to A. This. That means volume of the semicircle. So if you calculate it, that means this is you have to minus it. That means if this much, this fluid, that means we'll just draw the diagram, no problem. That means first this one, beta. Okay, this is your how much? A, D, C, B. This is your, and this is your upward direction. Then upside. No problem. This much, this amount, so this to minus, so you have to only this semicircle, only this semicircle. This fluid, and this will act in downward direction. This will act in downward direction. So this minus this is your semicircle. So net forces, this is higher than this one, so net forces in upward direction. So if there is any curve, very important, if there is any curve and fluid is outside, the net vertical force is downward. And in any curve which inside the curve the fluid is present, the net force is always, vertical direction is upward. So in this case, the net force in upward also. In this case also, that means a net force is always in a upward direction. That is called buoyancy effect. This is called buoyancy effect. So in this case, ultimately, this is the buoyancy force. See, buoyancy force is the net hydrostatic force in the vertical direction. So either the fluid outside the curve or inside the curve, the net force is on the vertical direction. So this force will passes in the vertical direction, and this force, the net vertical force, will act at the CG. This is passes from the CG. Very important. This is at the CG. So one point always remember beta, that the horizontal force, net horizontal force and net vertical force, that means FH is equal to rho G, height of the center of the pressure, into area of the vertical plane, AV. If V is rho G into volume displaced, that means weight. This is nothing, this is weight. And this is act at a center of pressure, and this is act at a CG of the fluid which is contained inside the curve. So this is at CG, this is at center of pressure, and the center of pressure is the CG of pressure triangle, pressure diagram. So you don't confuse, this is at CG, this is at CG. The vertical force is passing through the CG. The vertical force is passing through the CG. And vertical force is nothing, it is the weight of the fluid content inside the, displaced, content or displaced. See, if this is a flat surface, so you just displace, this is a fluid displaced, so the force is at outward direction. See, there is a horizontal surface. If you pull backside and there is a fluid, and if you pull backside and you make a curve, so this amount of the fluid will displaced. This amount of the fluid, so this is a fluid displaced. The amount of the fluid displaced when you are stretching, when you pulling the curve and to make a curve from the flat to curve. Why? Because when there is a flat, horizontal force is there. Now, when there is a flat, horizontal force is there, the net horizontal force you calculate it, and this is at center pressure of the vertical plane. Now we calculate the vertical force. That plane you stretch it and make a curve. And suppose to that this force vertical is the weight within the curve, weight of the fluid displaced. Weight of the fluid displaced. How much the fluid will displaced? जितना आपने इसको stretched किया है. So this is at CG. So this is at CG and this is at CP. So this CG, this is the semicircle, and what is the CG of the semicircle? 4r by 3 pi. This is your CG of the semicircle, 4r by 3 pi. So this is your net vertical force. How to calculate this? Rho G into V. Right. You know rho G. 9810. And this is your volume. What is the volume of this circle? What is the volume of this circle? Pi into pi r square. What is the r? 3. So 9 divided by 2. This is the area into the depth is 4. So this is your vertical force. And what is that? This is your 176.58 pi kilonewton. So you have to a vertical force. See, this is your diagram. This is your data. What you have to calculate? You have to a horizontal force. This is the net horizontal force. What is that net horizontal force? I have a data, no problem. 706.32 kilonewton. 32 kilonewton. And it is act as CP, and CP is 2 meter. Okay, from the base, this is from the base. Now there is a FV net vertical force. This is your how much? This is your 176.58 pi. This is your 176.58 pi kilonewton. And it is act as a CG of a displaced fluid. And this is what CG? 4r by 3 pi. If you put the value 4r by 3 pi, then this is your 4r ki value 3 divided by 3 into pi. So this is your 4 by pi meter. This is from the base. From the base of the semicircle. Base of the semicircle. This is from the base of the semicircle. This is from the base of the semicircle. Now we calculate the net hydrostatic. See beta, what is the location of this and this force? So this is due to hydrostatic force, and also there are two pairs of the forces also asking the question. What is that? Reaction at a B. A B is the hinge, and what is the support reaction at A? So indirectly you have to calculate 1 horizontal force, net hydrostatic force, 2 net vertical force, 3 at the contacting point at A, and 2 at the hinge. Why? Because at the hinge there is no any moment. Only the force is, see, at what is the equilibrium force? The equilibrium force, net horizontal force, net vertical force, and there is a momentum. 3 equilibrium condition na. Net horizontal force is 0, net vertical force is 0, and net moment at that point is 0. There are 3 equilibrium condition, right? So for the this force is due to hydrostatic force. So this force is due to. Now we make a free body diagram. From there we have to calculate one thing is that what is your C and resultant force. Determine the resultant force. See, my dear, I erase it. See, determine the resultant force that water pressure exerts on the plate. That means what pressure exerted by the water on the plate. By the water on the plate. What is the force? What is the force? So water will exert on the plate is the hydrostatic force. And it is a curved surface, so there are 2 forces. Net horizontal force and net vertical force, and square root, then you calculate the resultant force. So for the resultant force, you have to calculate horizontal force, you have to calculate vertical force. Now beta, that means, see, that means free body diagram. Oh, just we calculate resultant force, na? So what is the resultant force? Fr is what? Square root of F of horizontal force, F of vertical force. See, F of vertical force. Put all this value, this one and this one, and you have to get an answer 898 kilonewton. This is your, this, what is this force? This is net hydrostatic force. This is your net hydrostatic force. And see, there is a frequently asked in the interview questions, what is the cause of the buoyancy force? From where the buoyancy force will act? The buoyancy force is acting due to this net hydrostatic force. Due to this net hydrostatic force, okay, buoyant force. So in the buoyancy, horizontal is no effective, like both sides are the balance. So the net vertical force, that means net hydrostatic force in a vertical direction, net hydrostatic force in a vertical direction, either upward or downward, it may be, net hydrostatic force in a vertical direction will responsible to create a buoyancy force. Will create a buoyancy force. Okay. So this is net force. Now, if you draw a free body diagram to calculate the reaction, right? So we have this of the plate, okay. Now at this point there is RA, this is your RA, this is your RA, this is your RA, okay. We can consider this is force A. This force will provide due to the contacting point, right? This is the hinge, right? This is your 6 meter. This is your 6 meter, no problem at all. This is your 6 meter, okay. Now from here, this is the line of action of a vertical force. This is the line of the net vertical force, FV, and this is at a distance. You have this distance. You have this distance. What is that? 4r by 3 pi, and this is what? 4 by pi meter. You already calculate. This is the line of action of vertical force, and this is your line of action of horizontal force. This is your line of action of horizontal force, FH, and this is at the hinge. How much? How much it is? It is at 2 meter. It is at 2 meter. It is at 2 meter. Now, this is and there is a vertical force. So there is a reaction is Bx. This is point number B. Bx, and this is your By. By, this is your Y, no problem, Y direction. This is your By, and this is your Bx. See my dear, you don't bother about in which direction we take a reaction. आप कभी भी ये टेंशन मत लेना कि किस डायरेक्शन में इसको रिएक्शन को ले. Don't bother about that. We take any direction, either upward, downward, backwards, leftward, rightward, no problem. Don't confuse कि sir taken in the downward direction we take. We intentionally taking, why? Because vertical force is only upward direction, so it balance, maybe it is downward direction, no problem. But you may take any direction, right? Okay. Now this is the reaction, and this is your free body diagram. Free body diagram of the plate. This is your free body diagram of the plate. Now, what is your equilibrium equation? The equilibrium equation is net force in x direction. What is that? Net force in x direction. We take in this direction is positive is equal to 0. What is the second equilibrium condition? The net force, vertical force in x direction is equal to 0 and vertically upward is positive. What is the third equilibrium condition? The net momentum at any point O is equal to 0 and taking it is anti-clockwise is positive, clockwise. So this is your equilibrium equation. You know all these things. You know all the things. Okay. This is your equilibrium. Three equilibrium. From this three equilibrium condition, this is positive beta. This is positive, right? Anti-clockwise positive. So this is your equilibrium equation. Oh, this is your x, y. This is your y direction. So net force in x direction is 0. Net force in y direction is 0. Net moment at any point is 0. This is the equilibrium. And from this equilibrium condition, you can find the any type of the reaction. So if you find force at A, so this is in which direction? Horizontal direction. So we take this one. So net force in horizontal direction, what is that? FA is minus FA is equal to plus FH. Yes or not? Horizontal force. What is the horizontal force? If you take horizontal force, so we take second page, no problem. So first equilibrium condition, either second equilibrium, you may take any one of this and apply. There is a, see, FA, FB and FBX and BY. There are three equations, there are three unknown and there are three equations you can easily solve. There are three equations, Fx, Fy or Mo, and there are three unknown you can easily solve. You can easily solve, there is no any problem. So you can add like that. First we apply this one, vertical. You can apply anything for any type. So summation of all the force in y direction is equal to 0 and taking upward as positive. Upward as positive, right? No problem at all. So what is that? Upward force is, what is that? By is equal to Fb. That means By is negative, Fb is positive. Fb is positive. Fb is positive minus By is equal to 0. Only these two force in a vertical direction. This one and this one. Right? And you know Fb. You know Fb. Put this value Fb. So what is the Fb? That means 176.58 pi minus Bx is equal to 0. So your Bx is 555 kilonewton. This is your reaction at B. This is your reaction at B. This is your reaction at B. Okay. Now beta, one you know FB. Now you know Bx. So for that, now FA you have to apply net horizontal force is 0. FA, for FA net horizontal force is 0. So we take next summation of all the forces in x direction is equal to 0 and take in x direction, in this direction is positive. Okay. So from the figure, what is FA minus FA plus FH plus FH plus FH minus Bx is equal to 0. And you have all this value, yes or not? So you have all this value. You have all this value. FA you have, Bx you don't have, Bx you have, FH you have. From here, FH you have. From where? Here you can find easily FA. Yes or not? Why? Because you have Bx. This is your By, not Bx. This is your By. Y direction. This is your By. So, see, this is in this questions you have only FH. You don't have Bx, right? You have FH. You don't have a FA. You don't have a Bx. So you cannot find this one. So this equation is hold it at it and apply the next momentum equation. Next, and is sum of all the momentum at point O is 0. Why we taking the momentum at point O is 0? Why? Because moment at point O there is a hinge. Okay, so take this point at a momentum is 0. So we take FA and we take anti-clockwise is positive. So FA produce anti-clockwise direction. FA into perpendicular distance positive. FH is negative. FH into 2, right? FV into pi by 4 is positive. So this creates a momentum negative. This creates a momentum at about A. This creates a momentum negative. This creates a momentum negative. This creates a momentum positive. This creates a momentum positive. Why? Because this is in positive direction. This is in negative direction. This is in negative direction. Balance it and you can find FA. Why? Because you have FH. You have this FV. You have this FA. So you can find easily reaction at point A. Yes or not? Apply this. So what is this equation? This is equation FA into 6. I am writing here, no problem. FA into 6. Yes, it is like that. FA. This is FA into 6 minus FH into 2 minus FH into 2 plus, yeah, this is also minus FV into pi by 4 minus FV into 4 by pi. This is equal to 0. You have FH, you have FV, put that, and there is FA is 353 kilonewton. This is your net reaction at the support A. Net reaction at the support A. Now you have FA, you have By, put here. FA you have, FH you already have, put here Bx. So from here you can easily find Bx. And what is the value of Bx? I come up with what is the value of Bx? Bx is 535. Same. 353. Bx is 353 kilonewton. So this is your Bx. This is your complete questions. Mind it, it is not a lengthy question. It is a little bit lengthy question, but it will create so lots of equation. This is a pure fluid mechanics, hydrostatic. Also there is a mechanics. So this is the basics you covered, that it creates develop lots of concepts behind the mechanics, how to calculate the momentum, how to calculate the force, and also how to calculate the hydrostatic force. So hydrostatic force, mind it, this is your fundamental. This is a very fundamental. Horizontal force act as the CP, and CP is what? CP is what? CP is your CG of the pressure diagram. FV is the net vertical force. It is act as a CG. Cg, what Cg? Cg of the fluid, Cg, that means Fv is nothing, Fv is the weight of the fluid which is contained in the body, and it is passes through the Cg of that chunk of the body. And what is the Fr? This is a net reaction, net force due to horizontal and vertical. See, if you consider buoyancy, horizontal force is 0, square root of Fv square is Fv. So the buoyancy is net vertical hydrostatic force. Okay, like that. Now, the next problem is this one. This is your next problem. This is your next problem. See, same questions asked in the GATE examination. There, its shape is differ. Here is a trapezoidal shape, and at that point there is a circular shape. So in this series we are avoiding the taking a GATE question. We are only the formation of new question. So equivalent question we are in front of you. That means उसी के equivalence question, उसी से equivalent questions हम लेके आए हैं. टोटली हूबहू आपको क्वेश्चन नहीं मिलेगी. ओके बेटा, जैसे प्रीवियस ईयर में यहाँ पे सर्कुलर डिवाइस था, सर्कुलर, हमने यहाँ पे ट्रेपेजियम ले लिया है. ओके, सो इसको देखिए. ओके निखिल, ओके निखिल, थैंक यू. See, okay, so this is your container, that means a plug. This is your plug. This is, one second beta, read the questions first. Read the question, all of you please read the question. All of you please read the question. Okay, please read the question, no problem. Please read the question beta, all of you. Please read the question, all of you. Please read the question, all of you. See, this is very, very important question here. I'm telling you, this is very, never found in the YouTube channel. Never found. Okay. See, a plug in a figure is 50 mm long. 50 mm long. Has a trapezoidal cross section. Trapezoidal cross section. Cross section is how? Trapezoidal. Has a trapezoidal cross section. If the tank is filled with the crude oil, there is a crude oil. Determine the resultant vertical force acting on the plug due to the oil pressure. That means this is your oil. This is your oil beta. This is your oil. This is your oil. Okay. This, due to presence of this oil, what is the resultant vertical force? What is the resultant vertical force? Okay. 5 meter long, that means this trapezium, this trapezoidal shape have the width, that means it is the perpendicular to the board, have the length 50 mm. It is a 50 mm. So what is the net hydrostatic force? See, here is the missing is here is the density of the crude oil given in the question. What is that? I give you density of the oil is given beta. It is given 880 kg per meter. This is given. This is given. Data is missing, no problem. The data is given. This is given. Okay, beta. Density of crude oil. Okay. Now, how to find it? First of all, how to find it, beta? How to find it? See, there is a plug. See, what is the application of these questions? See, see beta, why this question is designed? Why this question is designed? See, very important. If we withdraw the oil from the tank, you apply the pressure from this one. You apply the force on this plug. On this plug. So plug is moving up and the oil is drained out. Oil is drained out from the side of the plug. So this this type of situation is practically used. So what force is applied to this, what force, yeah, what pressure is applied on the plug, yeah, what pressure will applied by the oil on the plug? This have to be knowledge. So how to calculate? See there, how to calculate? First of all, see, due to this, see, this is your plug surface where the fluid is contacting. This is your plug at which the fluid is in contact in this. So see beta, at this surface, horizontal surface of the plug, the oil exerts a pressure downward in this downward in this fashion. Yes or not? And thank you, yes sir. And due to this inclined surface, the fluid will exert in this direction pressure. Yes or not? Fluid is exerting this direction of the pressure. Yes or not? So it have a two component. One is vertical component, other is horizontal component. One is vertical component, other is horizontal component. Horizontal component is cancel out, so there is a vertical force. So due to vertical force, there is a vertical pressure exerted by the fluid. Due to this incline, the fluid is inclined, so due to inclination, there is a component of a vertical pressure. Okay, vertical pressure, and thank you Gaurav, and there is a vertical downward, so net force, yeah, net pressure will create the resultant vertical force. That means, see, if this is your plug, see, okay beta, this is your see, this is your dimension is given, and see, if this is your plug, if this is your plug, so if you consider this on this hydrostatic force, this is in this direction. So beta, this hydrostatic force will create, this force will create net vertical, and this will create net vertical. So net vertical will create how much column of the water? How much column of water? This to this, you project it at a free surface. Why? Because it will create a vertical force. It will create a vertical force. It will create a vertical force. So this hashes portion is the hydrostatic force due to the inclined surface, and if you, due to this force, the vertical component will create a force on the projection to this free surface. That means कहने का मतलब ये हो गया बेटा कि इस inclined surface पे जो हाइड्रोस्टेटिक फोर्स लग रहा है उसका नेट वर्टिकल कब लगेगा? इसके कंपोनेंट जैसे देखिए, सपोज इफ यू सपोज देयर इज अ फ्री सरफेस, if there is a free surface and there is a one inclination here and there is a one inclination here, so how much the vertical force will act? You take a projection of this one above that, so fluid content within this projection is the net vertical force due to this portion. If we contain this one, project it to the vertical free surface, so the fluid weight of the fluid which is contained within this projection is the vertical force. So there is a one in this, there is a vertical force, in this there is a vertical force, and there is a one also there is a horizontal force on this one. vertical force on the horizontal surface on this one. So in this one, there is this fluid content only. This fluid content only, yes or not? This fluid content only. So what is the net force? This is your FV1, this is your FV2, this is your FV3. So FV3 is only due to FV3 is only due to this portion. If you project it to the free surface, this is due to FV3. Right? And FV1 is due to this one. Okay, so what is the net vertical force? See, there is a large portion of the vertical force, have a large portion, so net force, resultant force is in downward direction, or forget about all the thing. You take resultant force. So what is the resultant force? FV3 downward minus FV1 plus FV2. Yes or not? What is the FV3? This is the vertical force. So we know that what is the vertical force? Rho g into volume. Rho g into volume. So the vertical force for this one, rho g. Now volume of this portion, rho g is same for all the portion. So volume of this portion, yani if you say that if R is equal to rho g outside into FV3, that means volume of 3 minus volume of 1 plus volume of 2. Yes or not? So volume of 3 is what? This is the rectangular image, volume of 3. What is the volume of 3? This length into this length into the depth perpendicular to the board. So what is the FV3? This is rho g at, is it? What is FV3? How much this one? This is 20 plus 10 plus 10. That means 40 and 0.04 meter. This horizontal dimension. What is the vertical dimension? What is the vertical dimension? From here, not from here. If you doing rapidly in the GATE examination, you may have to mistake it. So careful. 99% student get confused and you take 15 also. No, it is up to this height. Why? Because in this portion there is no any fluid. In this portion there is no any fluid. So in this portion only there is a fluid. So we take a height 60 mm. Okay. Now this is your 60 mm. Now beta, one second. So this is your 0.06. Okay. Now what is the depth? What is the depth? The depth is 50 mm. The depth is 50 mm. So 0.04, 0.05. So this is a volume of this rectangular portion. Now we take a volume of this HH portion, red color portion. So this, what is the V1? So V1 and V2 are same. See the beauty. This is, why? Because this is 10, this is 10, this is 15. So this age is same. So this are same. So we take 2 of V1. No problem. From this one, we take 2 of V1. Right? So minus 2, what is V1? You take this triangle, area of this triangle plus area of this rectangle. into depth. Into depth. So what is this triangular area? Half into base. What is the base of this height? 10.01 into what is the height? This height 15 into 0.015. Yes or not? 15. Okay? Okay? This is okay? So this is your area into width. Width is 0.05. So this is your triangular portion. This is your triangular portion plus. What is that? This rectangle. This height is what? 10.01. This length. This height is what? Into 0.06. And this width is what? 0.05. Okay, I multiply with rho j. So if you multiply with that, beta, you may easily find the net force. So what is the answer? I will just write. The answer is FR is 0.453 Newton. 0.453. This is your net downward force. Net vertical force. This is your net vertical force. Okay. Tick. And this is your net vertical force. Okay, beta. Now we go to the next problem. Take this one. Take this one. Take this one, beta. Take this one. See, this is your question. A raft consists of uniform platform having a mass 2 megagram. Right? In 2000. What is that? It is 2000 kg. Right? This is 2000 kg. And 4 floors. These are the floors. 4 floors, each of the mass 120 kg. And length, that means the floors have a perpendicular to the board is 4 meter. Perpendicular to the board is 4 meter. Okay. Determine the height. Very important. Determine the height h. This height h, at which the platform floats from the water surface. Take, this is your density. Take 1 milligram, that means 1000. किसका water का 10 to the power 3 kg per meter cube. This is your density. Okay. This is okay, beta. This is okay. So draw, find it. Find it, beta. What is the approach of this equation? What is the approach, beta? What is your approach? Please reply. What is your approach? What is your approach, beta? See, beta. See, this is in a floating condition, right? Yes or no? This is floating. Uniform plate having a mass itna and floats having a mass itna. The length is floating. See, either the body is inside, yani fully submerged or partial submerged. What is the equilibrium condition? The equilibrium condition there are 2 equilibrium conditions. There are 2 equilibrium conditions. Number first, what is the equilibrium condition? I just give you. Here from here, no problem. I just give you beta. If the, see, see beta, what is that? If you find that what is given here, what is given here, mass of the platform is 2 cross 10 to the power 3 kg. Mass of each float is given, I think the mass of each float, this is very important. Mass of each float is given, how much? 120 kg. Okay, no problem at all. Length is given 4 meter. Okay. Density of the water is given 10 to the power 3 kg per meter cube, no problem. Right. We have to find H. What is the value of H? See very carefully. Determine the height H at which the platform floats from the water surface. That means, beta, think like that. If there is any platform, see, I will just show you. From that one, no problem. If there is any surface, right? See, if we put the things, there is a platform, okay? This is your platform and this is your leg, okay? You put it. Now, the question is say that what is the height? What is the height from the free surface? What is the height from the free surface? यानी कहने का मतलब what is the height from the free surface of water to the platform? This is your platform and the water is in this level. So if water is in this level, so what is the height? Mind it. Okay. If you see figure very carefully, if you see the figure of the floats very carefully, floats look like that. See, floats look like that. What is that? What is that? This is your floats. It is look like that. This is the floats. Yes or not? This is your floats. This is the floats, and see some part from the figure, some part is the semicircle. Some part is the semicircle. So if you draw a line, this is your semicircle. This is your semicircle. Some part is rectangle and the platform is placed it over it. So beta, whether this height is varying, if we put this weight on this platform 2000 kg, it may be totally submerged. That means one part is rectangle and other part is circular shape. So if we apply the weight, that means a mass on it, it may be fully submerged. Why? Because there is a two surface. There are two type of surfaces there. One is rectangle, other is circular. So if we apply the force on it, how much the part will submerged? So that you can easily find the, why? Because see beta, if this is our surface of water, let's suppose beta, if this is our water surface, let's suppose if this is our water surface, after the application of the force. That means fully submerged of the semicircle, and some part of the rectangle is also submerged in the semicircle. Submerged. Yes or not? Yes or not? So if you calculate, and what is asking that how much height from the free surface, this height you have to find it, this h height, this h height you have to find it, this height from the free surface. So how to find it, beta? You know this radius, you know this radius, and in that question there is one thing is missing. This is 0.5. That means the total height of the floats is, this is the total height from that, and this is also 0.5, and this is your yes, this is 2.5, this is 0.5, है ना, 0.25, no problem. So this is also, see, this is the circle, and that circle is touching this like that. So this height is also 0.25 meter. This height is also 0.25. So what portion will emerge into the rectangular, into the surface? This is your h minus 0.25. That means this is h 0.5, sorry, 0.25. This is what? This height is what? 0.25. Total height is 0.25. 0.25 minus h. This part is also submerged. But this is the hypothetical. First we will check it. Whether the semicircle is fully submerged or not. If this is fully submerged, then we assume that some part of the portion of rectangular may be submerged. It is not necessary that yes sir fully submerged, that means, मतलब कहने का मतलब ये कि सर अगर फुल्ली सबमर्ज होगा तो प्योर सर्किल के लेवल पे होगा, ऐसा नहीं समझ सकते. हम कह सकते हैं कि अगर जो वॉल्यूम ऑफ द सबमर्ज्ड है, अगर वॉल्यूम ऑफ द सबमर्ज्ड ज्यादा है, वॉल्यूम ऑफ द सबमर्ज्ड इज हायर देन द वॉल्यूम ऑफ this semicircle, volume of the submerged is higher than the volume of semicircle, then the semicircle is fully submerged. That means some portion of the rectangle is also inside the water. Or other sense is that if the submerged volume is less than the volume of the semicircle, then we can say that only the part of the semicircle will submerge into the fluid. Okay, so first we calculate. So this is equilibrium. So first we calculate what is the equilibrium condition. What is the equilibrium condition? There are two equilibrium conditions. In the case of there are two equilibrium conditions. First is the buoyant force is always, thank you Ankit. First is the buoyant force is always equilibrium with the weight of the body. This is the first equilibrium condition. And the second equilibrium condition is that the buoyant force and the weight of the body is a collinear in the same linear. This is the equilibrium condition. Number first is the weight of the body. That means weight of the body is exactly equal to the buoyant force. This is first equilibrium condition. And the second is that the line of action of the weight and the line of action of a buoyant force, both are the collinear. That means line of action of the weight and buoyant force are collinear. This is the equilibrium condition of a floating body or submerged body. This is the equilibrium condition. Okay. Okay, beta. Now next, चलते हैं. So first we check. Okay. So this is your diagram, no problem at all. Now, okay. This is the height over which. This is your height. This is your height over which we can take. This is your height. H, it is visible or not? Yes, it is visible. And this is 0.25. 0.25 is the rectangular side height. This is circular side height. And if you suppose that, so we assume that it is fully immersed. This is the circular portion. This is the circular portion, yes or not? This is the circular portion, yes or not? This is the circular portion, right? And this is the height of a rectangle. Okay. Let's suppose h height. So first we find that whether it is fully submerged or not. So what is, we are supposed to be say that this is a one floats. So what is the weight contributed? Yeah, what is the weight will act on the one float? So there is the mass will distributed. There is a 4 float, na 4 floats. So this mass is contributed on the all float. Thank you, sir. So there is a 4 floats. So if you contribute it, contribution, that means what is the mass will act, weight, what is the weight will act on this floats. This is the one floats. So the weight is 1/4 of this mass. Why? Because this mass is contributed to all the 4 floats. So 1/4 into 2 cross 10 to the power 3 plus mass of itself of the floats 120. Calculate it, beta. If you calculate it, this is weight, mass into 9.81. If you calculate, this is your 6082.2 Newton, and this is in downward direction. This is your downward direction. This force is balanced. This force is balanced by the buoyancy force due to equilibrium condition. This force is balanced by the buoyant force. So at equilibrium, this weight is equal to buoyant force, FB, buoyancy force, and it is act as the CG of the displaced fluid. CG of the displaced fluid. Okay. And what is the buoyant force? Weight of the displaced fluid. Weight of the buoyant force is the weight of the displaced fluid, so that the buoyancy force, it is the displaced force CG. Okay. Rho G into fluid displaced. Into fluid displaced. What is the displaced fluid? We have to find it. What is the displaced fluid? We have to find it. So what is the weight? Weight is, I have calculated, no problem, 6082.2, this is weight, is equal to 9810 into fluid displaced. So what is the displaced fluid? This is the displaced fluid. And what is the physical meaning of displaced fluid? Displaced fluid is how much the volume will immerse into the fluid. This will indicate that how much the portion of the body will immerse fully in the fluid. That means this is the portion portion of the body which is submerged inside the fluid. Submerged inside the fluid. Okay. So this volume of fluid displaced, this is equal to how much, beta? Just to calculate it, 0.62 meter cube. 0.62 meter cube. Okay, yes or not? 0.62 meter cube. Okay, no problem at all. Now we have find what is the volume of this semicircle. What is the volume of this semicircle? What is the volume of this semicircle? So volume of this semicircle is what? Now the next, that means this part of the inside the water, semicircle floats volume. Yani volume of semicircular floats. Circular float is what, beta? It is a semicircular. So half pi, what is R? 0.25 chi square into width. Width is what? 4. Volume, na? So if you calculate, this is your 0.4 approximately. This is your 0.4 approximately. If you calculate, this is approximately. See the beauty. See the beauty, beta. See, fluid displaced, that means the volume of the portion which is inside the water is higher than the volume of the portion of the semicircle. That means this is less than volume of the fluid displaced. So what's your conclusion? So the semicircle is fully immersed. So the semicircle is fully inside the water. So there is some portion of the water, some portion of the body will also immersed in the fluid. And what type of the portion? There is a rectangular portion. There is a rectangular portion. So this is the fluid displaced, that means volume of the portion which is inside the water, and this volume will contribute to the volume of the semicircle. Why this is less? Why this is high? Why? Because somehow in this volume there must be add of the some portion of the rectangle. That means the volume fluid displaced is higher. If you equate this, that means why this is higher? Fluid displaced higher. That means in this there's some portion. Why? Because if there is a circle will emerge into the water, only this portion is fluid displaced. If this is equal, that means if fluid displaced, if the fluid displaced is 0.4, yeah, volume of the semicircle is 0.62. That means we can say that only the circular part is inside the water. Only the circular part inside the water. But in this case, volume of the fluid displaced is higher than the circular part of the portion. That means some part of the portion of the rectangular portion is also inside the water. So in the fluid displaced, there is a volume of the circular plus volume of the some part of the rectangular. Okay. So we can say that sir, this is your portion. Okay, this is your portion. So some part, this is a circular portion, some part also inside the water. That means this is your free surface. This is your free surface. This is your free surface. Okay, beta? And this is your 0.25 right? How much this is above? This is your height h, you can calculate it. Okay beta, and this is also your 0.25 because this is approximately semicircle. Okay, so the fluid displaced, this is due to fluid displaced, volume of the fluid displaced is equal to volume of the, this is, let's suppose this is 2 and this is 1, volume of the part 1 which is submerged plus volume of the part 2. This volume of the part is semicircle, you have already calculated how much it is. It is approximately 0.3927 plus volume of this part, that means this rectangular is how much, this volume, this is how much, this volume 0.25 minus h is this part. What is this part? What is this part? 0.25 minus h. This is the height, and this is your how much, and this is what? See, this is what beta? 4 meter. 4 meter, na? I think this is a 4 meter. Yes, this is a 4 meter, and this is your 0.5. So 0.5 into 0.25. So this is your, I will write from here, no problem. So what is fluid displaced? 0.62 is equal to 0.25 minus h into 0.5 into 4. This is the volume of the rectangle, this portion which is immersed, plus volume of the circle, you have already calculated 0.3927. From this, you can easily find what is the height above which, what is the height from the free surface above which the platform will lie. So this is your approximately 0.136 mm. That means what beta? 1 mm hai na, this is mm, meter. This is not mm, this is meter. Okay, 0.136 meter. That means 136 mm, which is above from that, portion. That means the platform is 136 mm from the water surface. Okay. चलिए अब बनाते बेटा नेक्स्ट क्वेश्चंस. This is okay. Now I think up to that beta, we have to discuss about the static. Right? Now we have some problem of fluid kinematics. This is MCQ type question. Sorry, MSQ. Right? This is MSQ type question. Okay. See, in the fluid mechanics, beta, fluid kinematics probability of the fluid kinematics, probability in the fluid kinematics that create the MCQ is more. That means the formation of MCQ, multiple select question, in the fluid kinematics chapter is very, very high possibility. Very, very high possibility. So don't avoid the chapter of fluid kinematics, and along with that, above 50% of students have lack of knowledge of fluid kinematics due to two reasons. One is it have not very much confidence about the vector and also vector calculus. this subject, this chapter will require, thank you Dibyansu, this chapter requires the mathematical approach. It is not like in mechanics approach. This is the pure mathematical chapter, and from that mathematics you have a strong with the vector calculus and the vector calculus along with the vector. Okay, no problem at all. So see, we have the velocity component of a three-dimensional incompressible fluid. Three-dimensional incompressible fluid, the velocity component in x direction is xy, in y direction is 2xyz minus में, in z direction omega is y minus yz plus z square. This is in x, y and z direction. Okay, no problem at all. Now, now beta, these are the very intelligent. See, there is a same one problem in which asking many type of the problem, right? So whether it is possible case of the fluid flow, see, where if you find the flow is possible or not, where the fluid is flow is possible or not, what you want to check? What you want to check? Whether the fluid flow is possible or not, what you want to check? Please reply. What you want to check? Whether the fluid is flowing or not, what you want to check? Please, everyone, what you want to check? You check a continuity equation. What you check? A continuity equation. Right. Right. The continuity equation is what? Continuity equation is what? Conservation of mass. Conservation of mass. Continuity equation was what, beta? Conservation of mass. Okay. So you if it is satisfied the continuity equation, then we said that the fluid is possible. Now next, whether the flow is rotational or irrotational, what you want to check? From where you want to check? Please explain. Please. What you want to check? The fluid is rotational or not? What you want to check? From what parameter you want to check? From what parameter you want to check? The rotational or irrotationality? Rotational or irrotationality, from what parameter you can check? You can check curl vector. From the curl you can check. That means del cross V vector. Curl of a velocity vector. You check curl of a velocity vector. You check curl of a velocity vector. If the curl of a velocity vector is 0, and what is the curl of a velocity vector? I will explain you, no problem. The curl of a velocity vector is 0, then the flow is irrotational. Then the flow is irrotational. That means not rotating. That means omega is 0. That means omega is 0. See, there is a rotation and there is a deformation. In the case of deformation, angular strain is there. In the case of rotation, there is a rigid body motion. Okay? Del cross B. Now, the angular velocity. What is the angular velocity? Omega z, omega y, omega x. You have to find angular velocity omega. Right? Now you have to find vorticity. What is the vorticity, beta? What is the vorticity? It is nothing. It is curl of a velocity vector. Vorticity is nothing, beta. It is a curl of a velocity vector. And a curl of a velocity vector is twice of the angular rotation. Is twice of the rotation. Is twice of the angular rotation. Right. Now the shear strain. You have to find shear strains and the dilatancy. And dilatancy is what? Volumetric strain. Shear strain, and this is your volumetric strain. So you have to find all the things in a single shot. Okay, in single shot you have to find all these things. Okay, so before that before that beta, I give some backup. Okay, 1 second. See, very important note. There is a very important thing. What is the note? See, there is one incompressible flow. One second, we write some smaller sense, not in big. Why? Because there are two things is there. So first, you have a note. What is that? Incompressible flow. One second. There is a flow. There is a flow and there is a fluid. There is a fluid. Agar in this case of the flow, if we check the flow is incompressible or not, is incompressible or not. Fluid is incompressible or not. Or not. There are two things. Flow is incompressible or not. Fluid is incompressible or not. Flow is incompressible or not. We check the volumetric strain. What is we check? Due to the volumetric strain. To metric strain. Due to the volumetric strain. And fluid is incompressible or not is due to the change in density or not. That means due to change in density. Due to change in density or not. So this is a very subtle concept I am telling you. This is a very subtle concept. What is that? If you check the fluid flow is incompressible or not, you may precisely check the volumetric strain. Go to the volumetric strain. And if say that fluid is incompressible or not, you check the change in density or not. Change in density or not. Right. What is the volumetric strain? What is the volumetric strain? What is the volumetric strain? That means rate of volumetric strain. Rate of volumetric strain is what? You know that? 1 by V dV by dt. This is your rate of volumetric strain. You know all the things. This is your rate of volumetric strain. If this is 0, if this is 0, the fluid is incompressible. The fluid is incompressible. If this is 0, that means the fluid is incompressible. That means a rate of volumetric strain. That means rate of volumetric strain is 0, then we can say that flow is incompressible. Flow is incompressible. Flow is incompressible, right? That is the material derivative. That is, बेटा मैं बता रहा हूं आपको, d of rho by d of t is equal to 0. This is the material derivative. I give you some little bit concept. d rho by dt is 0, right? How we'll write d rho by dt? That means this is a material derivative. Okay, no problem at all. Now see, if there is a flow of the fluid and we take a mass of the if there is an element and this element is flowing incompressibly or compressibly, we don't know, and this is flow. So what is the mass? Density into volume. What is the mass? Density into volume. If you apply this, that means the mass is density into volume, that means L n m. Take natural log in both sides, ln rho plus ln v. So from here we can say that 1 by m capital D m by dt plus 1 by rho capital d rho by capital dt plus 1 by volume v capital d by dt. Yes or not? So what is this, beta? What is this? This is what? 0. Why? Because mass is constant. Mass is constant. Okay. So what is that? 1 by rho d rho by dt plus 1 by v dv by dt is 0. Okay, is 0. That means this is what, beta? 1 by rho. Okay, this is what? This is what? Okay, this is constant. 1 by rho d rho by dt, 1 by v. So this is what, beta? This is what? Volumetric strain. This is what? Volumetric strain. This is what? Volumetric strain. Okay. So if we, and what is the volumetric strain? What is the volumetric strain? If there is a volumetric strain, that means the volumetric strain, if there is volumetric strain is 0, that means divergence of a velocity vector is 0. Divergence of a velocity vector is 0. That means flow is incompressible. That means continuity equation is satisfied. Okay, that means here we can write like that. This is what? Del dot v vector. This is what? Del dot v vector. And this is what? Divergence of a velocity vector. Divergence of a velocity vector. अगर ये 0 है, if it is 0, that means flow is incompressible, right? Flow is incompressible. Volumetric strain is 0. If the volumetric strain is 0, then the flow is incompressible. Then the flow is incompressible. So in that case, the flow is incompressible. Velocity vector 0, flow is incompressible. Flow is incompressible. Flow is incompressible. And what is the divergence of V? Divergence of a velocity. What is the divergence of a velocity vector? Del dot V is what? How to calculate, beta? What is the divergence? This is a scalar quantity. That means what is the divergence? Dou by dou x. Dou by dou x. Please, everyone. What is the divergence? del dot v vector is what beta? d by dx, d by dy, dou by dou z. This is your delta dot v vector, v, u, v and omega, right? And if you calculate it, dou u by dou x, dou v by dou x, dou omega by dou x, and this is a scalar. If this is 0, then the flow is incompressible. If this is 0, then the flow is incompressible. Right? Okay, no problem. So there is a one short is that here one concept of material derivative we will discuss. Material derivative. What is that material derivative? Capital D, और इसी को बोलते हैं बेटा और substantial derivative और substantial derivative. What is that? Substantial derivative. What is that? D of dt. D of dt is equal to d of dt plus, very important, v vector dot del. This is your material derivative. This is your temporal component and this is your convective component. This is your temporal component and this is your convective component. ये temporal component है बेटा, ये time dependent, ये space dependent. So material derivative sometimes is called total derivative. Sometimes is called total derivative. Right? Okay. अब इसमें हम इस चीज को ऐसे नहीं लिख सकते. That means don't write. What is that? Del dot v. Why? Because this is because of divergence of a velocity vector. ये क्या है बेटा? Divergence of velocity vector है. This is your divergence of a velocity vector. This is your divergence of a velocity vector. Now, see, if we write, very important, I give you one concept is that, एग्जाम्पल के रूप में इफ वी एग्जाम्पल ले लेते हैं एक्सेलरेशन. हमने मटेरियल डेरिवेटिव की बात कर रहे हैं, हम निकालना चाहते हैं एक्सेलरेशन ऑफ ए बॉडी like that. How to write material derivative acceleration of a body? That means dou of v vector by dt. Yes or not? So if dou of v vector, so put here v, so dv by dt, v into v dot del to v. That means here we can write dou v by dou t plus v vector dot del into v vector. Yes or not? See, very important. This is what? This is two component. And this is what? This is two component. This is the acceleration. This is the acceleration of a body. This is the acceleration. Yes or not, beta? This is the acceleration. This is vector. This is your acceleration. Time dependent. If the acceleration in x direction, you may take u. If the acceleration in y direction, you may take v. If the acceleration in z direction, you may take omega. Right? Accordingly, you have to take either. So this is your what? This is your rate of change in velocity, rate of change in velocity of a fluid at a point of a fluid at a point in a space, and this is your acceleration of the body due to motion through the velocity field. Motion through the velocity field. Through the velocity field. That's it. अब उस प्रॉब्लम को देखते हैं बेटा. अब हम उस प्रॉब्लम को देखते हैं. कौन सा प्रॉब्लम है? अब ये टोटल निकल जाएगा. आप ये निकाल सकते हैं. Fluid flow, continuity equation, rotational, irrotational, curl, angular velocity, omega x, omega y, z, vorticity. Vorticity is nothing. Vorticity is nothing. It is your curl of a velocity. That means vorticity की अगर बात करेंगे बेटा हम, अगर हम vorticity की बात करेंगे, अगर हम vorticity को very important, I'm telling you, अगर vorticity की बात करेंगे बेटा, vorticity is nothing. It is a curl of a velocity. And the curl of a velocity is 2 times of angular motion. Very important, I'm telling you. Very important. That means the vorticity is nothing. It is a curl of a velocity. A curl. What is, so that what is the vorticity indicates? The vorticity indicates the rotationality of the fluid. What is indicate? Rotationality of the fluid. That means this indicates rotationality. Of the fluid. That means if when there is a irrotational flow, that means not rotating, that means omega is 0, vorticity is also 0. Vorticity is also 0. That means curl of a velocity vector is 0. Curl of a velocity vector is 0. Okay. So this problem you may write. Solve this problem. Solve this problem beta. Solve this one. So there is, this is continuity equation. Just you find dou u by dou x, dou u by dou x, dou v by dou y, dou omega by dou z. Dou u by dou x, dou v by dou y, dou omega by dou z. Add this one, whether we check this is 0 or not, and I am saying that this is 0, so the flow is possible. That means continuity equation satisfied. Right? Whether the flow is rotational, just you check its curl. And the curl is, I think, the curl is not 0. Curl is not 0. The curl is not 0, that means flow is, curl is not 0. That means omega is there. Omega is there, the flow is rotational. The flow is rotational. Very important. Irrotational, but that means not rotating. Not rotating, that means omega is not 0. Not rotating, that means omega is 0. Omega, there is no any omega. That means omega is 0, that means I am not rotating. If omega is not 0, if omega is 0, that means not rotating. If omega is not 0, that means there is a rotation. Mind it, there is a irrotational, that means not rotating, right? Angular velocity, omega x, omega y, omega z, right? Vorticity, directly you write vorticity, this one. This is your vorticity, where it is. This is your vorticity. Vorticity, you just write vorticity, curl of a velocity vector. So you just, may I solve? To solve, otherwise we take another sort of the problem. Why? Because this is a very important problem. I will discuss you. You may solve it, no problem. You may solve it with yourself. I am discussing one of the very important, very important. This is my favorite question. I am saying this is my favorite question. So it will solve, no problem. All the concept is given you. Now, this is your practice questions. This is your practice question. You, two-dimensional velocity potential function. Velocity function, potential function is phi is given. Then you have to find up this one. Determine the velocity vector. Velocity component in x and y direction you may write. So that the flow is possible. Continuity equation. Satisfy the condition of irrotationality. You may check curl. determine the stream function and the flow between the stream lines, flow rate between the stream function you have find, that means your stream function psi, and what is the flow rate. The flow rate is the difference between two stream function. This value is gives the flow rate. Discharge between the why? Because at a fixed streamline, stream function is fixed. So the discharge is in between the two streamline. So psi 1 minus psi 2 gives the discharge. You may find it. Also show that the streamlines and potential line intersect to each other. So streamline you have a slope, potential line you have a slope. If you multiply it and if its results is -1, so it is orthogonally. And yes, it is orthogonally, always orthogonally. Okay, no problem. Just we give the next problem. See, I have a next problem. This is very important problem. I'm telling you, this is very important problem. What is that? Three component of the velocity is given. U is given. What is U? Ax. V is minus ay. Omega is 0. Three velocity is given. This is what? Flow field. What is called? This is called flow field. This is called flow field. Right? Calculate the pressure. Calculate the pressure between 2 point. That means delta P 1 and 2. Okay. Given the condition is given. Given is very important. Non-viscous. This is non-viscous. Number second, density is constant. Number third, G along, that means gravitation along Z direction, and steady flow. Number 4 is steady flow. Number 4 is steady flow. This is given to you. This is given to you, right? See, if this is your non-viscous, if there is a fluid element and it have inviscid, the fluid is inviscid, then in this condition we apply the Euler's equation of motion. And if there is a viscous, we apply the Navier-Stokes equation. So Euler's to Navier, only that there is a viscous fluid. There is nothing difference. This both are the momentum, conservation of momentum equation. Both are the force equation, right? So there are three equations: continuity equation, conservation of mass, Euler's and Navier-Stokes equation, conservation of momentum, and energy equation, conservation of Bernoulli, conservation of energy, Bernoulli equation. Okay. So this is non-viscous. Non-viscous, that means you apply Euler's equation of motion. What is that? Euler's equation of, what is that? Euler's equation of motion. What is that? Euler's equation of motion. And beta, what is the Euler's equation of motion? You know all the things. See, if you derive very fastly, I have time, no problem. See, Euler's why I'm saying why, because this is your very simple fundamental things. That means this is your Newton's second law of motion. of motion. This is your Newton's second law of motion. This is Newton's second law of motion. See, if there is a fluid element, right? If there is a fluid element and this fluid is flowing in x direction, only we take a x direction. So the pressure exerted on the fluid in this side is P. There is a delta x, dimension is delta x, delta y, delta z. This is a fluid element. So what is the pressure? According to Taylor's series, P plus dou P by dou x into P plus dou P by dou x into delta x. This is the pressure. Now, if we balance this pressure, the motion in along x-axis. Motion is along x-axis. So this force will, why? Because there is no any shear stress. Why? Because there is inviscid fluid. There is a inviscid fluid, so there is no any surface force. Only the force is the body force, and also there is a pressure force. No surface force. Why? Because there is no any shear stress. Why? Because there is inviscid fluid. There is a inviscid fluid. Okay, no problem at all. So what is the force in x direction? Net force in x direction, Fx, due to pressure only. Lastly, we add in that direction, no problem. So P, what is the force? P delta y delta z, delta y delta z minus P plus dou P by dou x delta x. This is your delta z delta y, delta z delta y, right? Now if you take this one, so this is your minus dp by dx, x direction, dp by dx, delta x delta y delta z. This is your force in x direction. Always remember this one. That means force, the fluid is flowing and force along the x direction, inviscid fluid, force along the x direction, due to pressure, it is not, is a negative pressure gradient into volume of that fluid element. Always remember this thing. Always remember, in y direction minus dou P over dou y delta x delta y delta z. In z direction there is a body force, so add this mass into, density into volume into density, mass by volume. So mass into volume, if you will density term, you make a density term, right? So this is your force in x direction due to pressure gradient. So what we can write, there is a very important note you can write here. What is that, beta? What is that? This is a volume. So the force on the fluid element is due to the pressure. If the pressure is applying, this flow is due to the pressure only. If the pressure will change, the force, that force is equal to the minus grade of P into volume of that element, Very important, I'm telling you. This gives your feel inside. The force, if we apply the pressure, if the fluid is moving, inviscid fluid is moving with the help of pressure, what is the force? Gradient of the P into the volume. That means grade of the P. And why it is negative? Why? Because it is flowing in the high pressure to low pressure, so it is negative. What means it's negative? That negative is always like that, the flow is high pressure to low pressure, so it is negative, decreasing pressure, so it is minus, right? Okay, no problem. Now this is one thing, this is due to the pressure, Now this is in motion. The motion have an acceleration. Due to this motion, due to this pressure, the fluid element have a motion. Due to this pressure, the fluid element have a motion. If the fluid element have a motion, so there must be acceleration. So due to that acceleration, there must be a force. What is the force? That means force due to the acceleration. That means force due to the acceleration is equal to mass into acceleration. Yes or not? Right? And for the Q. And what is the mass? Density into volume. Delta X, delta Y, delta Z. This is your volume into acceleration, beta. Into acceleration. What is the acceleration? dV by dt. Very important. And this acceleration is the material derivative acceleration due to the field. So we can write dou V by dou T also. Right? Material derivative. Okay. Now we equate this. This is equation number second. This is equation number first. These two equations are same. Why? Because this force will create acceleration. This force will create a motion. And due to that motion, there is a force. So these two are same. Very important. So equating first and second. If you equate it, so minus grade of P is equal to rho dV by dt. Very important, I'm telling you. This is very important. This is called Euler's equation. That's it. Simply, this is called Euler's equation. Right. See, it is not included here in the body force, but we include that body force. This is the net, this is mass into acceleration, this is net force. This is what? A net force. Net force. So if you write Euler's equation at randomly in any direction, the standard format is what? That rho dou V by dou T is equal to minus grade of P plus rho of body force vector. That's it. This is your Euler's equation. This is your Euler's equation in the form of vector. There is any problem? This is your net force is the body force also. If we make this equation in the form of Navier-Stokes, you add viscous force also. Okay, you add viscous force. So this is your Euler's equation. This is my favorite topic, beta. So I am not able to reach directly on the problem. Why? Because you know this. If you feel that the flow is you derive the Euler's equation, you don't bother about that question. Go through the basic. It is not that advanced. It is a basic thing. Very fundamental things. From the fundamentally you can prove it. From the fundamental, there is no any fluid mechanics. There is no any fluid mechanics there. Only the mechanics. This is only the mechanics and plus mathematics and little bit a vector. Right? Okay. So this is Euler's equation. Okay. So if it is in, if we can, the Euler's equation is conservation of momentum. Euler's equation is conservation of momentum. No problem. Okay. So you can write now. This question is where? So this is velocity is given, and to find the pressure between these two velocity field. Pressure between these two point in the velocity field. So what is that? We write this is the Navier-Stokes equation. So this is the Navier-Stokes equation is the momentum equation. Navier-Stokes equation is momentum equation. Okay. Continuity equation is mass equation. Mass, conservation of mass equation. Okay. So what is that? You have to remember it. No problem. So rho dV by dt material derivative is equal to pressure gradient plus body force plus body force. That's it. That's it. Okay. So we take x momentum equation. Or how can we write? This is the material derivative, that means temporal component plus convective component. This is the acceleration. This is the acceleration. This is the force. Mind it. And if you, this is the force. Okay. X momentum. This is x momentum. And how can we write x momentum? See, rho, split it this material derivative, dx, so u by dt. Now you take a convective acceleration. So u dou u by dou x plus v dou u by dou y plus बोल ओमेगा dou, जल्दी बोलिए, ओमेगा dou u by dou z. This is the acceleration, is equal to, what is the x direction? Minus dou p by dou x. This is x direction, plus body force in the x direction is 0. Why? Because in the question there is given the body force is along, g is along z direction. So this is cancel out. This is, if you write, then you write rho bx, no problem. Body force in x direction. Now you take cancel out. The flow is STD. The flow is STD. So this is 0. This is 0. Why? Because flow is STD. Flow is STD, right? This is 0. Why? Because no body force. Body force along x direction, right? This is also 0. Why? Because two-dimensional flow. See, this is our two-dimensional flow. Omega is 0. Third component is 0. Two-dimensional flow. 2D flow. So the net equation is rho u dou u by dou x plus v dou u by dou y equal to minus dou p by dou x. This is the equation. Now if you put that equation, if you put this one and write and integrate it, and you take a pressure along x-axis. Now similarly pressure along y-axis. Now similarly pressure along z-axis. But when you write a pressure along z-axis, you can never neglect the body force. You can never neglect the body force. Why? Because the z direction have a body force. And what is the bz? Bz is minus g. Bz is minus g. Okay. So this is your x momentum. Now what is the y momentum? Okay. First of all, we may solve it, no problem. So if you put that one, u, what is u value? U dou u by dou x, put, you know u dou u by dou x, put this one here. We will calculate. So density, if you put that one, density into this is ax into a plus minus ay into 0, this is equal to minus dp by dx. So what is that? Rho a square x is equal to minus dp by dx, right? So what is the pressure? If you integrate it, this is minus rho a square x square by 2, and the function, kiska function? If it is in x direction, so y and z. This is the pressure along x direction. This is the pressure along x direction. Now, due to the momentum. So how? So there is a very important information from the momentum equation, how to get a pressure equation. This is the pressure equation. Okay, this we find from the given data. Okay, no problem. Now we find the pressure along y-axis, momentum along, conservation of momentum into y-axis. So y momentum equation. Right? What is the momentum equation? What is the momentum equation? Rho dv by, always remember, dt is equal to minus grade of p plus rho b vector. B vector kar do, B vector. Right? Now we write acceleration. So dou v by dou t plus u dou v by dou x plus v dou v by dou y plus omega dou v by dou z is equal to minus dou p by dou y or plus density body force along y direction. See, this is 0, steady, this is 0, two-dimensional, this is 0, no body force. Now we put all this value, and from here you can get pressure along x-axis minus rho a square x square, no, y momentum, a square y square divided by 2 plus f2 xz. This is the pressure along x-axis. This is the pressure along x-axis. Now we can find pressure along y-axis. Pressure along y-axis. Pressure along z-axis. So write z direction momentum equation. What is that? Rho del. What is that? Z direction. If you write, then the z direction momentum equation, beta, z direction momentum equation is simply, see, we'll write rho dv vector by dt, this is acceleration, is equal to minus del p plus rho b z. सही, ठीक है, राइट, यहां से स्प्लिट दैट, सो रो, दिस इज डी ओमेगा बाई dt, this is 0 plus u dou omega by dou x plus v dou omega by dou y plus omega dou omega by dou z. Okay, right, minus dou p by dou z plus, right. Now here is the confusion is there. What is the bx? Bx is g or minus g. See, this is your z direction, right? This is your z direction, and this is your acceleration direction, double arrow g. So bx is always positive. Bz is always positive. Bz is always positive. So it is negative. So put here bz is always minus g. Here is a confusion. Put here b is minus g. So this is your minus rho into z. Put all these values 0, 0. So from here we can find minus, why? Because all these things is 0. All these things 0. This 0, this, all these things. So this is your minus dou p by dou z is equal to rho into z. If you integrate it, this p is equal to minus rho gz plus function f3. If you integrate z direction, the function is x and y. This is the pressure along z direction. This is the pressure along z direction. Now, if you have a pressure along x-axis, pressure along y-axis, pressure along z direction. So how to calculate the Navier-Stokes equation from the pressure equation? This is the fundamental thing, right? Now, now the next task is that we find F1, F2, F3. We find F1, F2, F3, right? So if you find F1, see, if you find F1, F2, F3, this is your here. This is your F1, F2, F3. We have find it. So if you find, what is the trick here? Anyone please? If you find, see, if you find F1, F1 what? What is the F1? What is the F1 beta? F1 is Y and Z. How to find? See, see beta. If you find F1 now, okay, first I write this equation here, please. Why? Because every time we are not supposed to be able to that cut, no problem. X, Z, okay. So what is that? X direction momentum equation. Here we can write, no problem. X direction momentum equation, that means X momentum equation. X momentum equation is P is equal to minus rho A square X square by 2 plus F1 XY. This is X direction momentum equation. Y direction pressure minus rho A square Y square by 2 plus F2 XZ. What is Z direction? P is equal to P is equal to the minus rho GZ plus F3 X into Z. This is equal. Now we find F. Now we find F1 XY. So we search where is the X? This is X and this is Z direction, no? X, XY. I heard what Y. This is X. This is X. No. This is YZ. This is X equation, no? This is YZ. Okay. So you have to find YZ. This is YXZ, and this is your Z. So this is your Z, na? XY. Okay. Now you find XY. If you find XY, so if you find XY, that means F3. F3 XY. What is F3 XY? XY. Here X here, Y here. X here, Y here. Put that one. FXY. XY. So there is FXY. F3. 1 second. We'll check. No problem at all. We'll check. Beta. There is some confusion is there. 1 second. X momentum. F1 YZ. F2 XZ. F3 XY. Right. If we find F3 XY. F3 XY. So F3 XY. X is there, Y is there. You take this one. So this is your, from here, minus rho A square by 2 X square plus Y square. This is your Fx3. 3. Right? F2, if you find F2 XZ. So this is your X, this is your X, and this is your Z. So there is minus rho X, rho A square Y square by 2 plus, minus Y square by 2 F2 XZ, XZ, XZ. X is there, Z is there. So rho A square X square by 2, rho A square X square by 2 minus rho GZ. This is your F2. What is F3? F3 is XY. F3, find out. F1. F1 is what? YZ. What is Y? Y is here. Z is here. Write down. This is your minus rho A square by 2. This is F1 na, YZ. Y or Z. This equation is F1. F1 is this one. Y square minus rho G Z. So you have to find F1, F2, F3, F4. Now you take any one equation. If you take this one, to put this value F1 here, and then you integrate and we take 2 point nearby. We take 2 point. Put this one. Put this one. We take this one. Take. And put F1, this value into this one. And then integrate. Then if you integrate, the value is P is equal to minus rho A square X square by 2 minus rho A square Y square by 2 minus rho Z Z plus C constant. Right? So what is that? P plus half, write down, rho A square, there is A square is there, rho A square X square plus Y square, no, X square not Y square, this is not X square Y square, okay, no problem, plus rho G Z is equal to constant, okay, okay, and this is your what? Put two point P1 and P2, solve it, you must have delta P is what? No problem. Delta P is what? No problem. Okay. So, beta, this is your today's session. Will take not we are not able to finish total topic beta, but I will give you some insight how to take approach of a fluid mechanics. Now, in the next session, I have a heat transfer and its date will announce very soon. I think it is 17 or 18. But the next session of the in the civil department there is a open channel flow. Will take open channel flow also. Why? Because without open channel flow you can never achieve the good score marks in the civil engineering. So it is very mandatory to that attend the open channel flow, particularly for the civil engineering. Yes, okay, okay, beta. Bye bye. Good night.